So let's take this from the top. We want to first of all verify that the function f of x equals x cubed plus 2x minus 1 has an inverse, and that means we need to verify that it's 1 to 1. And then we're going to find the f inverse prime, that is the derivative of f inverse, at 2. We can evaluate it using our formula. Recall that if we want to find f inverse, I'll write it over here, f inverse prime of x, our rule tells us that it will be 1 divided by the composition of f prime of f inverse of x. So how should we do it here? Well, if we're interested in finding f inverse prime of 2, we would have to use this formula to get there. So let's assure ourselves that we can get there by finding out whether or not this function is 1 to 1. A function is 1 to 1 if f of a equals f of b is true if and only if, and I'll abbreviate that with IFF, if and only if a is equal to b. How can we assure ourselves of that here? Well, let's make a substitution. If we take a cubed plus 2 times a minus 1 and find some other number, a equals b, right? So we're going to take b cubed plus 2b minus 1. We want to assure ourselves that this is only going to be true if a is equal to b. So, in order to verify that that's true, let's go ahead and do a little bit of math right here. We can add 1 to both sides, and we come up with a cubed plus 2 times a is equal to b cubed plus 2 times b. And I know I can factor right here, and I'm going to get a times a squared plus 2 will equal b times b squared plus 2. Well, how do we know that this indicates that it's a 1 to 1 function? Well, let's pick two numbers and let's see what would happen. I know that I could pick two different numbers for a and b, and they could be the same. Let's for example say that we chose a equals negative 1 and b equals positive 1. Well, I know that a squared plus 2 would equal 3, and b squared plus 2 would also equal to 3. But a is equal to negative 1 and b is equal to positive 1, and these two aren't equal, right? In other words, the only way that this statement right here could be equal is if a equals b. So we know that this is a 1 to 1 function. All right, so how do we use this fact to help us right here? Well, all right, we want to find f inverse prime of 2. To do that, we're going to have to take 1 over f prime, which we can figure out pretty easily, of f inverse of 2. All right, so there's sort of our issue. What is f inverse of 2 going to be equal to? Well, f inverse of 2 would equal the same number that f of that number would equal. So we want to figure out, well, what will give us 2 right here? Well, that means that we would have to find out what value of x from our original function, x cubed plus 2x plus minus 1, would equal 2. This is equivalent to saying finding where x cubed plus 2x minus 3 is equal to 0. Well, how do we know that one? This is not an easily factorable function. Well, it is a polynomial, and we know that in certain polynomials we can use the leading coefficients test to come up with a set of possible rational zeros that would solve this equation. And our list of possible rational zeros in this case include positive or negative 1 and positive or negative 3, right? Because it's factors of 3 over the factors of the leading coefficient 1. So let's figure this out. Which one would be it? Well, let's just try some numbers. Let's test it by synthetic division. Let's try positive 1. That's a nice, easy number to check. We would put our coefficients 1, x cubed, 0, x squared, don't forget the placeholder, 2, x minus 3. Does that work? Bring down the 1, multiply, add going down the column, 1, multiply, add going down the column, multiply, add going down the column. Sure enough, 1, x equals 1 is a 0. X equals 1 is a 0. And what is that? Well, that means that f of 1 is equal to 2. And therefore, f inverse of 2 must equal 1. And how does that help me here? Well, f prime of x, the derivative of our original function is 3x squared plus 2. So if we want to find f prime inverse of 2, we're going to do it by taking 1 over f prime of f inverse of 2, which is 1. So f prime, which is 3 times 1 squared plus 2, means that 1/5 is the value of our derivative at x equal of our derivative of our inverse at x equals 2. And we didn't even have to know what that inverse was to find it.